Hello students, in this lecture we are going to discuss some applications of Newton's second law of motion. Fine, as we know that force is equals to rate of change in momentum according to Newton's second law of motion. Fine, so from this relation we have that force is inversely proportional to the time. Inversely proportional to the time means if you increase the time of impact, then the force will decrease. Clear? I am repeating again. If you increase the time, then the force will decrease, as we have relation F is equals to P2 minus P1 upon T, means F is inversely proportional to the time. Inversely proportional means if time increases, then force will decrease. Now let us discuss the first application of Newton's second law of motion. First application is a fielder while catching a ball pulls his hands backward. Fine. When the fielder pulls his hand backward, in that case the time increases. Fine. While catching a ball, fielder pulls his hand to increase the time. If the time increases, then the force of impact decreases. Fine. So in that case, fielder hurts less. Fine. Now the second application is automobiles are fitted with shockers to reduce jerks. Fine. So automobiles are fitted with shockers. The purpose of the shockers is to increase the time of impact of the jerk so that the force of jerk experienced by the passenger sitting on the vehicle is less. Clear? Now the third point, the third application. In a high jump athletic event, the athletes are made to fall on cushioned mattress. Fine. So the third application is in a high jump athletic event, the athletes are made to fall on cushioned mattress. Fine. When an athlete falls on the mattress after his high jump, the mattress is slowly pressed downwards, which increases the time of impact, hence the force decreases. Fine. The fourth application is a person falling from a height on a hard cemented floor gets injured but does not get injured on grassy or on a heap of sand. Fine. So the application is a person falling from a height on a hard cemented floor gets injured but does not get injured on grassy or on a heap of sand. Fine. If the person falls on the heap of sand or on the grassy surface, the time of impact increases. Hence, the force decreases. That's why he does not get injured. But on the cemented floor, the time is very less. The time of impact is very less, so the force increases. So the person gets injured. Clear? The fifth application is electronic items or crockery or the chinaware are wrapped with bubbled polymer sheet or packed in thermocol boxes. Fine. So the fifth application is electronic items, crockery or the chinawares are wrapped with bubbled polymer sheets or packed in thermocol boxes. Fine. If these items are mishandled, the time of impact increases due to the soft nature of thermocol boxes. As a result, the force of impact decreases. Fine. Due to this reason, the glasswares, crockery or the chinawares, they are packed in thermocol boxes. Clear? Now, the sixth application. When a fast moving train collides with a stationary train, huge damage is caused to the moving train. Fine. When a fast moving train collides with the stationary train, huge damage is caused to the moving train. Fine. As the result of collision, the moving train suddenly comes to rest and the rate of change of momentum of the moving train is extremely large. Fine. As the result of this, force of impact on the moving train is extremely large, which causes a huge damage of moving train. Clear? Which causes a huge damage to the moving train. Fine. These are some applications of Newton's second law of motion. I am repeating again. We have the formula F is equals to P2 minus P1 upon T, means force is equals to rate of change in momentum. If you increase the time of impact, then the force will decrease because force is inversely proportional to the time. In the first application, we have discussed a fielder while catching a ball pulls his hand backward to increase the time of impact and to decrease the force. Second, shockers are provided in the vehicles to increase the time of impact again. In a high jump athletic event, athletes are made to fall on cushion matters. Cushion matters, the purpose of this cushion matters is to increase the time of impact and to decrease the force. Fine. Similarly, a person falling from a height on a hard cemented floor gets injured because the time of impact is very less in the case of cemented floor, so the force increases. Clear? All the crockery, chinawares and the electronic items, they are wrapped or packed in thermocol sheets, fine, or thermocol boxes to increase the time of impact, fine. Sixth application is when a fast moving train collides with stationary train, a huge damage is caused to the moving train, fine, because the time of impact is very less, fine. So in that case the force increases. So these are some applications of Newton's second law of motion. Clear? Thank you.